Download this code from codegive.com, link in the description below. Referential integrity, foreign keys, and updating/deleting data, a comprehensive guide. Referential integrity is a crucial concept in relational databases. It ensures that relationships between tables remain consistent and valid. This guide will delve into referential integrity, focusing specifically on foreign keys and how to handle update and delete operations while maintaining database integrity. We'll cover the principles, constraints, and practical code examples using SQL. 1. Understanding referential integrity and foreign keys. Referential integrity. Referential integrity is a system of rules that a relational database uses to ensure that relationships between tables remain consistent. It prevents actions that could break these relationships, leading to orphaned records, records that refer to non-existent data. Foreign key. A foreign key is a column, or a set of columns, in one table that refers to the primary key of another table. It establishes a link between the two tables. Think of it as a pointer that ensures the data in one table relates correctly to the data in another. Primary key table, parent table, the table containing the primary key to which the foreign key refers. Foreign key table, child table, the table containing the foreign key that references the primary key of the parent table. Example. Consider two tables, customers and orders. Customers table. Customer ID, primary key. First name. Last name. Email. Orders table. Order ID, primary key. Customer ID, foreign key referencing customers. Customer ID. Order date. Total amount. In this example, the orders table has a customer ID column that's a foreign key referencing the customer ID column in the customers table. This relationship signifies that each order must be associated with an existing customer. We wouldn't want to allow an order to be placed for a non-existent customer. This is precisely what referential integrity and foreign keys help us enforce. 2. Defining foreign key constraints. When creating a table with a foreign key, you define a constraint that enforces the referential integrity rule. This constraint is specified as part of the table creation or can be added later using an alter table statement. SQL syntax, general. Explanation. Foreign key, column _name, specifies the column, s, in the current table that form the foreign key. References parent _table _name, parent _column _name, specifies the parent table and the column, s, that the foreign key references, usually the primary key. On update action, defines what happens when the primary key in the parent table is updated. On delete action, defines what happens when a row is deleted from the parent table. 3. On update and on delete actions, maintaining referential integrity. The on update and on delete clauses are critical for specifying how the database should handle updates and deletes in the parent table that affect the foreign key relationships. Here's a breakdown of the common actions. No action, or restrict. This is the default action in many database systems. If you attempt to update or delete a row in the parent table that has corresponding rows in the child table, where the foreign key is used, the database will reject the operation and raise an error. This ensures that you cannot create orphaned records. Cascade. If you update or delete a row in the parent table, the corresponding rows in the child table are automatically updated or deleted to match. On update cascade. If you update the primary key value in a customer's table, any orders that reference that customer ID will automatically have their customer ID updated to the new value. Asterisk on delete cascade asterisk if you delete a customer from the customers table, all corresponding orders in the orders table will also be deleted. Use this with extreme caution. Deleting parent records can trigger a cascade of deletions, potentially wiping out related data you might want to keep. Asterisk set null asterisk if you update or delete a row in the parent table, the foreign key column in the corresponding rows in the child table is set to null. This is only possible if the foreign key column in the child table is nullable, i.e., allows null values. Asterisk on delete set null asterisk if you delete a customer, the customer ID in the orders table for that customer will be set to null. This means the order will no longer be associated with a specific customer, but the order record itself remains. Asterisk set default asterisk similar to set null, but instead of setting the foreign key to null, it sets it to a default value that you define for that column. This requires that the column has a defined default value. 4. Code examples, SQL Server. Let's illustrate these concepts with SQL Server examples. The specific syntax might vary slightly depending on your database system, MySQL, PostgreSQL, Oracle, etc., but the core principles remain the same. Explanation of the code asterisk. 1. Table creation asterisk the code creates the customers and orders tables with appropriate columns, primary keys, and the foreign key relationship. Notice the onUpdate cascade and onDelete set null clauses in the orders table definition. 2. Data insertion asterisk sample data is inserted into both tables to demonstrate the relationships. 3. onUpdate cascade demo asterisk the update statement changes the customer ID in the customers table. Because of onUpdate cascade, the corresponding customer ID values in the orders table are automatically updated. 4. onDelete set null demo asterisk the delete statement removes a customer from the customers table. Because of onDelete set null, the customer ID in the orders table for that customer is set to null. 5. Referential integrity violation asterisk the commented out insert statement attempts to insert an order with a customer ID that doesn't exist in the customers table. This will violate the referential integrity constraint and the database will throw an error, preventing the insertion. 6. Cleanup, optional the drop table statements remove the tables from the database. Use this only if you want to clean up after testing. 5. Considerations and best practices. Asterisk choose the right action asterisk carefully consider the business requirements when choosing the onUpdate and onDelete actions. The choice depends on the specific relationships between your tables and what should happen when data is modified in the parent table. Cascade is powerful but potentially dangerous, while set null requires careful planning for how to handle null values in your application. No action is often the safest starting point to prevent accidental data loss. Asterisk indexing asterisk ensure that foreign key columns are properly indexed. This significantly improves performance when querying data that involves joining tables based on foreign key relationships. The database typically creates an index automatically when a foreign key constraint is defined, but it's a good practice to verify. Asterisk performance impact asterisk cascade actions can have a performance impact, especially on large tables. The database system needs to automatically update or delete related rows, which can take time. Consider the performance implications when designing your database schema. Asterisk complexity asterisk deeply nested foreign key relationships, example table A-table B-table C, with cascade actions can become complex to manage and debug. Careful planning and thorough testing are crucial. Asterisk application logic asterisk sometimes, you might prefer to handle updates and deletes in your application code instead of relying solely on database constraints. This gives you more control and flexibility but also requires more responsibility for maintaining data integrity. If you choose this approach, be sure to implement robust error handling and validation to prevent data inconsistencies. Transaction management. Always wrap related update and delete operations within a transaction. This ensures that either all operations succeed, or none do, preventing partial updates that can lead to data corruption. Documentation. Document your foreign key constraints, including the on-update and on-delete actions, in your database schema documentation. This makes it easier for developers to understand the relationships between tables and the potential impact of data modifications. Testing. Thoroughly test your database schema and data modification procedures to ensure that referential integrity is properly enforced and that updates and deletes behave as expected. Create test cases that cover various scenarios, including updates, deletes, and attempts to violate constraints. 6. Example, using setDefault. Let's say you want to associate orders with a general customer if the original customer is deleted. Important note: finding the constraint name is crucial. In SQL Server Management Studio, SSMS, you can find the constraint name by right-clicking on the orders table, selecting Design, and looking at the foreign key relationships. Alternatively, you can query the system catalog views. 7. Common errors and troubleshooting. Referential integrity violation error. This is the most common error. It occurs when you try to insert, update, or delete data in a way that violates the foreign key constraint. Carefully review the error message to identify the specific table and column causing the problem. Cannot drop constraint. You might encounter this error when trying to drop a table or column that is referenced by a foreign key constraint. You need to drop the constraint first before dropping the table or column. Circular dependencies. Avoid circular dependencies between tables where each table references the other. This can lead to complex update and delete scenarios and make it difficult to manage referential integrity. Reevaluate your database design if you encounter this problem. In summary, referential integrity and foreign key constraints are essential for building robust and reliable relational databases. Understanding the different on-update and on-delete actions and carefully considering the business requirements will help you design a database schema that maintains data consistency and prevents orphaned records. Always test your database schema thoroughly to ensure that referential integrity is properly enforced and that updates and deletes behave as expected. Remember that the specifics might change based on the database system you are using, but the underlying principles are the same. Good luck.